Hello, my name is Cody Din, and today I am going to be presenting about nuclear energy and how it generates electricity. First, let's look at the history of nuclear power. The science of nuclear fission was developed from 1895 to 1945, but most development happens between 1939 and 1935, which focus mainly on creating atomic bombs. And as you may know, that period of time was the Second World War. This image right here shows the destruction of a nuclear bomb. Since 1945, the attention was given to harnessing this energy in a controlled fashion for naval propulsion and for making electricity. My areas of research would be how electricity is generated, creating steam with thermal energy, creating steam through nuclear fission, followed by nuclear fission and chain reaction of nuclear fission. And last but not least, how nuclear energy is better than thermal energy. First of all, let's look at how electricity is generated. Steam is first created and blown into the turbine generator to spin the turbine blades, which causes the cold wire cylinder to rotate, generating an electricity. The electrical output is then sent to the electrical power grid. But where does the steam come from in the first place? This question leads to my main argument. Nuclear power is more environmental friendly and more fuel efficient than traditional thermal energy. Creating steam with traditional thermal energy, aka traditional fuel. Traditional fuel consists of coal, oil, and natural gases. Factories first burn the fuels to create extreme heat and evaporate water into steam. But aside from heat, the combustion of these types of fuel also release an extensive amount of CO2 gas, which leads to this, the emission of greenhouse gas, and causes pollution and of course greenhouse effects. So now let's look at creating steam through nuclear fission. Extreme heat is also created to turn water into steam, but from a chain reaction in nuclear fission. Uranium-235 and uranium-238 are the two most popular materials for nuclear fission for their high degree of instability. So first let's look at what nuclear fission is. Nuclear fission is the decomposition of large unstable nuclei into smaller, more stable nuclei. As you can see on the screen, one neutron entered uranium-235 to decompose its nucleus into barium-141 and krypton-92. 3 new neutrons and of course energy as heat primarily. Underneath the diagram is the equation for nuclear fission, which will be mentioned later on. However, these 3 neutrons could continue entering other uranium nuclei and continue decay into antimony 132, niobium-101, strontium 93, and xenon 140, so on and so forth. So, how is nuclear power plant better than traditional thermal energy plants? Nuclear plants produce from almost zero to zero restraint air pollutants such as sulfur, carbon dioxide, while its energy is the largest source of emission-free energy in the world. As you can see in this equation that I mentioned before, uranium-235 plus 1 neutron yields 1 krypton-92 plus 1 barium-141 plus 3 neutron plus energy. There's no existence of sulfur, carbon dioxide, or any other greenhouse gas or any other air pollutants, which causes no harm to the environment. Furthermore, nuclear power is also very, very powerful. This is the end of my presentation. All the links and sources will be in the description box below. However, two questions remain. First, what is the infrastructure of a nuclear power plant? And are there any limitations to nuclear power plants? To answer one of those questions, please click the first link to the description box below. Thank you for listening.